Artemis II will experience something that no human has ever experienced before. For more than 53 years, no human being left low Earth orbit. Not even once. It was the longest gap in exploration since we first learned how to leave our planet. And that gap ended 4 days ago, when a rocket carrying 4 astronauts punched through the Florida sky and set its course for the moon. Artemis II is not a repeat of Apollo. It is not a sequel. The crew flying right now: Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, are doing things inside that spacecraft that Apollo astronauts could not have imagined. Some of what they are experiencing would have sounded to engineers in 1972 like pure science fiction. So what changed over half a century? Almost everything. Start with the spacecraft itself. The Apollo command module gave its 3-person crew about 210 cubic feet of habitable space. That is roughly the interior volume of a large closet. 3 grown men sealed inside a closet for up to 14 days. Orion gives its 4-person crew 330 cubic feet. Nearly 60% more room. That is about the space of 2 minivans parked side by side with the seats removed. Still tight. Still claustrophobic by any normal standard. But the difference between a closet and 2 minivans matters when you are 250,000 miles from the nearest hospital and you have not been able to stretch your legs in a week. The extra space is not just about comfort. It changes what the crew can physically do. Orion has a dedicated hygiene bay with doors that actually close. There is a toilet. The Universal Waste Management System, nearly identical to the one on the International Space Station. It collects urine and feces separately, processes them, and does so with something Apollo astronauts never had: privacy. The Apollo crews used plastic bags, adhesive bags that they taped to their bodies, used in front of each other, then sealed and stored inside the cabin for the rest of the mission. Nearly every Apollo astronaut who has spoken honestly about the experience describes it as one of the worst parts of spaceflight. The Artemis II crew will never experience that particular indignity. And honestly, that alone might be worth the 53 years of waiting. Then there is exercise. Apollo astronauts did not exercise in space. There was no room, no equipment, and on missions lasting less than 2 weeks, NASA decided the muscle and bone loss was acceptable. The Artemis II crew exercises every day except on launch and landing days, for 30 minutes each time, using a device called a flywheel. It weighs about 30 pounds and fits into a space roughly the size of a carry-on suitcase. It works like a yo-yo, a cable-based system that provides resistance proportional to the force you apply. Up to 400 pounds. You can row on it. You can do squat. You can do deadlifts. For context, the exercise equipment on the International Space Station weighs over 4,000 pounds and takes up 850 cubic feet. The flywheel delivers a surprising amount of the same function with only a fraction of that mass. Apollo had nothing. The crews came home weak, and some of them could barely stand. The Artemis II crew will return having performed deadlifts in zero gravity on their way to the moon. Which is a sentence that would have sounded completely absurd to anyone alive during the Apollo era. The rocket that carried them there is a different machine as well. Apollo flew on the Saturn V, the most powerful rocket ever built at the time, generating 7.5 million pounds of thrust at liftoff. The Space Launch System that carried Artemis II off the pad on April 1st produces 8.8 million pounds, about 17% more. Both rockets are expendable, meaning they fly once and are gone. Which feels almost old-fashioned in an era when SpaceX lands boosters on drone ships. But SLS was not built to be economical. It was built to send Orion and its crew toward the Moon in a single launch, with no orbital assembly, no refueling, and no docking required to leave Earth's neighborhood. Saturn V did the same thing. The difference is what sits on top. Apollo was powered entirely by fuel cells and batteries. Hydrogen and oxygen combined to produce electricity. And, as a useful byproduct, drinking water. It was elegant, but limited. Every watt the crew used came from a tank that was slowly running out. Orion unfolds 4 solar array wings after reaching space. Each one covered in photovoltaic cells that convert sunlight into electricity. The power supply is, for all practical purposes, unlimited as long as the sun is shining. This changes the psychology of the mission in a subtle but important way. Apollo crews were constantly managing consumables, always aware of the clock ticking down on their oxygen, their power, and their water. Orion's crew still has to manage consumables. Oxygen and water do not come from solar panels. But the electrical margin is fundamentally different. The spacecraft systems can run longer, harder, and with greater redundancy because the power source regenerates itself. And the service module, the section of the spacecraft that provides propulsion, thermal control, and life support, was not even built in the United States. It was built by Airbus Defence and Space in Europe and provided by the European Space Agency. Apollo was an American project from the ground up. Artemis is international by design. A Canadian astronaut is on this flight because of a treaty signed in 2020. European hardware is helping keep the crew alive. The next phase of the program involves the Lunar Gateway, a space station that will orbit the Moon. With modules contributed by multiple countries and space agencies, the era of a single nation going to the Moon alone ended when Apollo ended. What replaced it is more complex, slower, and less straightforward. But it also means the cost, the knowledge, and the risk are shared. Now look at what is behind the panels. Orion's flight computers are roughly 20,000 times faster than Apollo's. Apollo's guidance computer had about 72 kilobytes of memory in total and could execute around 40,000 instructions per second. A modern smartphone easily surpasses it. Orion runs 4 independent computers in parallel. Each one is about 25 times faster than the computers on the space station and 400 times faster than those used on the space shuttle. The cockpit is entirely digital, with glass screens, software-driven interfaces, and real-time trajectory adjustments. Apollo's cockpit relied on analog switches, dials, and physical gauges. Astronauts had to read instruments manually and calculate corrections, with ground control handling most of the complex math. Orion can, in theory, fly itself. It demonstrated that during Artemis I in 2022, when the uncrewed spacecraft completed a full lunar mission and returned to Earth autonomously. That matters more than it might seem. Apollo astronauts were, in many ways, passengers on a vehicle that depended heavily on constant ground control. Mission Control in Houston made most of the critical decisions. Orion shifts that balance. The Artemis II crew has been performing manual piloting demonstrations in deep space, physically flying the spacecraft and testing how it responds across different steering modes, evaluating how the vehicle behaves when a human is actively in control. Apollo astronauts did fly manually during certain phases, especially docking and landing. But they never flew the command module freely through open space the way Hansen just did. This spacecraft is being designed for a future where astronauts may need to operate independently, far from Earth. In situations where communication delays of even a few seconds to the Moon or up to 20 minutes to Mars make ground control ineffective in an emergency. Speaking of communication, Apollo crews spoke to Houston using radio waves, essentially the same technology as an AM radio station, just directed toward the Moon. It worked, but the audio was often rough. The bandwidth was limited, and transmitting a single photograph could take several minutes. Orion still has that radio capability as a backup, but its primary system for high bandwidth data is something entirely new: laser communication. The Orion Artemis II optical communication system uses infrared light to transmit data back to Earth at speeds that would have been unthinkable during Apollo. By the fourth day of the mission, the system had already downlinked 100 gigabytes, including high-resolution photographs captured through Orion's windows. Apollo's total data return from an entire mission was measured in megabytes. The Artemis II crew is now streaming high-resolution imagery from deep space in something close to real time. When Christina Koch looked back at Earth through Orion's window, and that image appeared on screens around the world within hours, that was laser communication, doing something radio never could. The views themselves are different as well. Every Apollo mission that reached the Moon flew at approximately 70 miles above the surface, close enough to see individual craters and to watch the line between day and night move slowly across the terrain below. Artemis II will not get that close. At its closest approach during the flyby, Orion will be about 4,660 miles from the lunar surface. That creates a fundamentally different visual experience. Instead of skimming over the surface and seeing only a narrow strip of terrain at any given moment, the Artemis II crew will see the entire disk of the Moon at once, from pole to pole, filling their windows. No Apollo astronaut ever had that view at closest approach. And because of the geometry of this trajectory and the timing of the launch, the crew will see something no human has ever seen with their own eyes: the Orion Basin. It lies along the boundary between the near side and the far side of the Moon. A massive impact crater, roughly 600 miles across. Robotic spacecraft have photographed it. Orbital instruments have mapped it, but no human has ever looked at it directly. The Apollo missions were planned so that the near side of the Moon was illuminated during their flybys, which meant the Orion region was always in shadow or just out of view. Artemis II changes that. NASA has confirmed that the crew has already photographed it through Orion's windows. For the first time, a human being has looked at a feature of the Moon and seen something that, until now, only machines had ever observed. There is also a solar eclipse coming. Not the kind seen from Earth, where the Moon blocks the Sun. This one happens when the Earth blocks the Sun. As viewed from the spacecraft's position behind the Moon, it will last approximately 53 minutes and occur about 1 hour after Earthrise. No Apollo crew ever experienced anything like it. The geometry never aligned. Artemis II was not specifically designed to create this eclipse, but the physics of the flyby made it unavoidable. And both the crew and the science teams on the ground are treating it as a valuable observation opportunity. Imagine watching your home planet, a thin blue crescent, slowly move in front of the Sun while you float behind the Moon in the deepest silence any human has ever known. Reed Wiseman described the view so far as something no amount of training could have prepared him for. He said you could see the entire globe from pole to pole. Africa, Europe, and if you looked closely, even the Northern Light. That was only partway through the transit. The flyby views will be something entirely different. The mission will also break the record for the farthest distance any human has ever traveled from Earth. That record currently belongs to the Apollo 13 crew. Not by choice. Their free return trajectory, after the oxygen tank explosion, carried them 248,655 miles from home. Artemis II is expected to reach approximately 252,757 miles. The difference is about 4,100 miles. That might not sound like much compared to 250,000 miles. But the symbolism matters. Apollo 13 set that record because something went catastrophically wrong, and the crew had to survive a slingshot around the moon in a crippled spacecraft. Artemis II will break it because the mission was designed that way from the beginning. The free return trajectory, which uses the moon's gravity to bring the spacecraft home without requiring a major engine burn, was Apollo 13's emergency plan. It is now Artemis II's primary flight plan. What was once a last resort has become the standard architecture, and at the end of all this, the Artemis II crew will face something no human has ever experienced at this speed. Re-entry. When Orion enters Earth's atmosphere on the way home, it will be traveling at approximately 25,000 miles per hour. That is faster than any crewed spacecraft has ever traveled during re-entry. Faster than Apollo. Faster than the shuttle. Faster than anything before it. The heat shield will endure temperatures approaching 5,000 degrees Fahrenheit as superheated plasma surrounds the vehicle and blocks all communication. For those minutes, the crew will be completely alone. Unable to speak with Houston. Unable to do anything except trust the engineering. That heat shield, by the way, carries its own story into this mission. After Artemis I returned in 2022, engineers found unexpected erosion in the ablative material. Portions of the shield had charred and flaked off in ways the models had not predicted. The underlying structure held, and the temperatures inside remained within safe limits. But the damage raised serious questions. NASA convened an independent review team and spent years analyzing whether the shield was safe for a crewed flight. Some engineers objected. Others argued for a redesigned shield before placing humans on top of it. NASA Administrator Jared Isaacman reviewed the data, met with engineers and outside experts, and ultimately gave approval. The shield flying on Artemis II is essentially the same design, with the understanding that further changes are planned for Artemis III. The crew knows this. They have accepted the risk. Every astronaut who has ever flown has accepted some version of this reality. The understanding that engineering is never perfect. That safety margins are real but not unlimited. And that exploration requires a willingness to go anyway. The crew itself also represents something Apollo never did. Victor Glover is the first person of color to travel beyond low Earth orbit. Christina Koch is the first woman. Jeremy Hansen is the first non-American astronaut to take part in such a mission. Hansen is Canadian. Selected through a treaty signed in 2020 between the United States and Canada that formalized Canadian participation in the Artemis program. Apollo was entirely American, entirely white, and entirely male. Not because NASA explicitly excluded others, but because the pipeline that produced military test pilots in the 1960s was itself limited and unequal. Artemis II does not erase that history. Nothing can. But it does mean that the first humans to see the moon up close in more than 50 years look more like the species they represent. There is also a quieter experiment happening inside the cabin that Apollo never attempted. The crew is being monitored for the biological effects of deep space radiation in ways that go far beyond what any Apollo mission tracked. Radiation dosimeters. Sleep pattern analysis. All of it is being recorded to understand what 10 days outside Earth's protective magnetic field does to the human body. In low Earth orbit, that magnetic field deflects most of the dangerous charged particles from deep space, trapping them in concentrated regions known as the Van Allen belt. The International Space Station orbits safely below those belts. Every crewed mission since Apollo 17 has remained beneath them. The Artemis II crew passed through both belts on the way out and will pass through them again on the way home, exposed to the very radiation those regions concentrate. Apollo astronauts did the same. But the medical monitoring at the time was far more limited. Some Apollo crews reported seeing flashes of light, even with their eyes closed, caused by cosmic rays striking their retinas. Today, we understand much more about those effects. We know the risks are real and cumulative. The data from this mission will shape how future deep space crews are selected and how long they can safely remain away from Earth for decades to come. Right now, 4 people are in deep space. That is the largest number of humans ever to be there at the same time in the history of our species. Apollo never sent more than 3 people beyond low Earth orbit on a single mission. Artemis II has 4. They are eating rehydrated meals warmed in a unit about the size of a briefcase. They are sleeping in bags attached to the walls of a cabin, not much larger than a walk-in closet. They are exercising using a 30-pound device that works like a yo-yo. They have already seen parts of the moon that no one alive has ever seen. And by tomorrow, they will have traveled farther from Earth than any human before them. And they are doing all of this in a spacecraft that is, if we are being honest, still a capsule. Bigger than Apollo. Smarter than Apollo. Better equipped. Better connected. Better in nearly every measurable way. But still a capsule. Still a metal shell with a heat shield on the bottom and a parachute system on the top. Designed to keep 4 people alive in the most hostile environment humanity has ever entered. The fundamental engineering challenge has not changed since 1968. You need air, water, food, heat management, radiation shielding, a way to slow down, and a way to survive the landing. 53 years of technological progress have made every one of those systems lighter, faster, more reliable, and more capable. But none of them have been made easy. The Artemis II crew will splash down in the Pacific Ocean sometime around April 11th. Recovery ships will be waiting. Airbags will inflate around the capsule to flip it upright if it lands on its side or upside down. A feature Apollo did not have. Divers will approach the floating spacecraft, open the hatch, and help 4 people climb out into the sunlight. Those 4 people will have completed the first crewed mission beyond Earth orbit in more than half a century. They will have tested every system that future crews will depend on to actually land on the moon. They will have seen things that change how they understand their own planet, their own smallness, and their own luck at being alive on the one world in the solar system where you can breathe freely. When the Apollo astronauts came home, they returned as conquerors. The moon had been the target, and they reached it. When the Artemis II crew returns, they will come back as Pathfinders. The moon is no longer the final destination. It is the first step. Everything this crew is testing: life support, navigation, the heat shield, communications, exercise systems, even the toilet is being validated, not just for future missions to the moon, but for the journey that comes after. Mars Orion has already been evaluated for a mission profile lasting 1,000 days when combined with additional habitation modules. The data the Artemis II crew is collecting right now, including how their bodies respond to deep space radiation, how they sleep, and how their cardiovascular systems adapt, will directly shape the spacecraft and mission plans that will send the first humans to another planet. Apollo proved that we could leave. Artemis is learning how to stay gone. Right now, as you hear this, 4 human beings are closer to the moon than anyone has been since December 1972. They are looking out through windows that are larger and clearer than anything Apollo ever had. They are transmitting images back to Earth at speeds that make Apollo's radio feel like smoke signals. They are flying a spacecraft that can think for itself. Built with modern manufacturing techniques, including 3-dimensional printed components, and powered by the sun, it carries the lessons of 53 years of trial and error, lessons paid for in failure. Patience, money, and time. They are not repeating what Apollo did. They are picking up a thread that was left in 1972 and pulling it forward, weaving something new. And tomorrow, they will pass behind the moon for 40 minutes. No signal will reach them. No voice from Earth. No data link. No connection to anything human except the 3 other people floating beside them in a capsule roughly 250,000 miles from home. The Apollo astronauts knew that silence as well. It is the one experience that has not changed. The moon still blocks the signal. The void is still the void. And for those 40 minutes, the Artemis II crew will experience something no technology can soften. The ancient and irreducible reality of being alone in the dark, farther from home than any road, wire, or signal can reach. That silence is the same. Everything else is new.